Yesterday, the physical design, it comprises of the entire components like things in IoT as well as what are the protocols involved. So what do you mean by things? How we are providing connection? What are the devices connected with, like which could be capable of performing remote sensing, actuating, monitoring capabilities, everything. So what for we are performing the things? It would be capable of exchanging the data with other connected devices and application, and it would be very much helpful for processing all those information from raw data to exact knowledge. Okay, for that purpose we are using that. And the IoT device consists of several interfaces, like it may be wired and wireless also. So what are all those things? The IO interface for sensors and interfaces for network connectivity, storage, as well as audio video interfaces. And coming for the protocols, we have different protocols. Link layer, um, link layer. What is the importance of link layer we discussed, followed by that what are the protocols involved in link layer, network layer, transport layer, and application also we discussed. So each and everything may have their own features. So we saw everything in last class. Fine. Next is this is about or physical things, what is exactly involved in IoT. The next comes logical design of IoT. It is visible, ma'am, slides?
Yes, ma'am.
Yeah, fine. So the logical design of IoT, it includes IoT functional block, IoT communication models, and IoT communication APIs. Okay. So physical is the component and structure. Logical means how we are providing connection logically. Okay. So that is it. So how will you define logical design? The logical design of an IoT system refers to an abstract representation of the entities and processes without going into the low-level specifics of the implementation. So this is the actual definition what is available in your textbook. So the logical design of an IoT system refers to an abstract representation of the entities and processes without going into the low level specifics of the implementation. So what is abstract? Based on the abstract, what is required, what are all comes in entity, what are all, which are all comes in processes. Entity means again the things involved. Processes in the sense what are the activities carried out in IoT. Okay, so that all comes in logical design. The next thing is an IoT system comprises a number of functional blocks that provide the system the capability for identification, sensing, actuation, communication, and management. So these are the 5 attributes which we require for performing this logical design. Okay, I'll repeat. An IoT system comprises a number of functional blocks that provide the system which have the capabilities, as a small mistake is there in the sentence framing, I'll change it out. System, the capabilities for identification, sensing, actuation, communication, and management. So these are the 5 attributes. So that was given in the functional block given as a diagrammatic representation. So the devices, what are all the things they are doing in functional block? Management, communication, services, security, and application. Okay. So this diagram I got it from one of the resources in Google. Fine. And what is device? Device is available at the low level layer, right? We are calling it as a low level layer. So what is device? An IoT system comprises of devices which provides different functions like sensing, actuation, monitoring, and various control activities. Okay, so those are what are the devices we are using? Everything is said to be the device category. The next comes communication. This handles the communication for IoT system, like which provide interface between all those devices. Okay, which provide interface between all those devices. The next is services. Excuse me. Excuse me, ma'am. Services in the sense for device monitoring, device control services, data publishing services, and services for device discovery. Okay, suppose you have some idea you have some idea to implement any task of IoT, and you are finding out a new innovative device. Okay, so that is said to be device discovery. What for we are using? 1 minute, ma. Excuse me. So the devices involved in various activities like monitoring. Monitoring means like a surveillance. Your camera, web camera, or surveillance camera, whatever you're using, that is meant for monitoring purpose. And control services means if you're choosing parking system, how the things are controlled, whether that slot is already occupied and these slots are free. Okay, so everything can be sensed and identified and controlled. Okay, so that is one type of example for controlling. And data publishing services in this means which could be capable of publishing that things. Okay, so like your websites, something like that. And services for device discovery in the sense which may be applicable to some innovation and creative ideas. Okay, so all those activities and all those services are possible with the help of IoT. The next comes management. And one more example I can say for publishing in the sense the news article, okay, magazines, everything is said to be few example. So how we can relate that and how it could be get published. Okay, management means this provides various functions to govern the IoT system. No, as what we have in our university, like VIT is managing something. So how it would be managed. So there are various functions which could be control and supervise and monitor. Security, this plays a major role in IoT. Some of the IoT tasks are having lack of security still. So it secures the IoT system and priority functions such as authentication, authorization, message and context integrity, data security. Okay. So authentication in the sense you're using your a password, something like that. So each and every device may have some ID. So based on that, we have to make use of that authenticate. Okay. So authorized means who is the owner actually. Okay. So who can do that? For example, copyright information is one example for authorization. And message and context integrity. How we are collecting data from different sources and how we are making use for our task. Okay. So whether it would be meaningful or not, context in the sense it would be relevant to the task or not. Okay, like that. Whether if you are collecting the data in such a way, it is safe or not. Okay, so that is a secure mechanism. And data security is normal data security. So how we can make our data as a private one as well as the public one. The finally comes application. The IoT applications provides an interface that the users can use to control and monitor various aspects of IoT system. For example, you have implemented a task, and if you want to obtain the output, or if you want to check whether the particular data is working properly or not, okay, particular system is working properly or not. So how will you identify? You can apply somewhere and you can check it out. Okay. So everything, the devices which could be used for application purpose. Your smartphone is a very good example for application oriented services. Okay. So how we are providing interface between that smartphone and your IoT device. So that is also main thing what we need for logical component. Okay. So what are the devices involved? How will you provide communication or interface between all those devices? What type of services it is carried out in logical, monitoring, control, publishing and data device discovery? How will you provide various functions to govern the IoT system? So if you are buying or purchasing a particular device, so how it would be managed? Security, so authentication, authorization, everything involve various priority functions. And application means where you are going to apply, in which specific areas. So that is also required for logical thing. And in that logical design, I told you this refers to an abstract representation of the entities and what are all the activities carried out there. So this consists of three things. First, we discussed now IoT functional block. This is the diagram, and this is the description. The next comes IoT communication model. This is the second task of logical design. This is the second task of logical design. How we are providing interface. There are various modes available. There are various methods available. So here we have, for providing logical connection for IoT communication models, we have request response, publish subscribe, push pull, exclusive pair. These are the 4 variants available here to provide communication model. In last class, I told you somewhere we discussed about request model, I think, right? I told that it will be discussed further. And where I'm not sure. Resource request model, we discussed that term. Okay, fine. So you can go through it later, or I will finish off and go through. So IoT communication models, we have 4 categories there, or 4 variants there. One is request response, second is publish subscribe, third one is push pull, and exclusive. Each and everything may have its own architectural diagram, and we should know what. You can say, take a request response model. So here we have client, server, and the resources will be provided to the server. Okay. So you know what is the concept behind client server, right? Can any one of you tell me what is the concept behind client server? We people are using in our day-to-day life, that client server system. Any idea about client server system, or what do you know about client server system? It may be right or wrong. Any volunteers?
Ma'am, client is the one which we use, and server is the one which the company sets up to talk with the client and send responses. So
Okay,
any
fine.
things like database communication and such things are done by the server.
Yeah, good, Hemant. What he said is right. So client is capable of requesting, and server is capable of providing all those services to the clients if they if they are having enough constraints. Okay, so all requesting, and they can't provide with that. Okay, so that is also there. So what we are searching in Google, we are the clients, and Google is providing us some data. So that is a one model, right? So the client sends the request to the server, and the server is capable of giving response to the clients. And what is actually happening in the what is the functionality of server exactly? Receiver receives request from the client, process the request, look up and fetches what are the various resources required, prepares the response, and sends the response to the client. Okay, ma? So that is what I have given you in green color box. Okay. In orange, you can find out what is the function of client. That's it. Sends request to the server. Okay, fine. So the arrow indicates request. It points to server. So what are the things happening there in the server? First thing is it receives request from the client. Second is it processes the request. Okay. And third is look up and fetches the relevant information what is required for the client, and then it will prepare the response and send response. Okay, ma'am? So this is what carried out in server. So for that I have given a bidirectional arrow to obtain the resource. Okay, to obtain the resource. So the request response is a communication model in which the client sends the request to the server and the server responds to the request. That's it. When the server receives a request, it will decide how to respond. Okay, fetches the data, retrieves resource representation, prepares the response, and sends the response to the client. Okay, so this is a simple task, but server having major functionality, more functions are there in the server. Okay, I'll tell you a very good example for this. I want to search something from the Google, like uh, kids information. Okay, I'm searching for my thing is, you can see, Yeah, I'll tell you orally because I have shared this slide alone. Again, it will come for that representation. I'll search in Google. So I'll tell you what is the example. We will have go through after this logical design descriptions. Fine. Suppose if I want to take some data which is required for me, my my theme is kids information. If I'm searching kids information, we could be able to retrieve different things, right? You know, right? Kids information means what type of food they are having, what dress they wear, and what is the some kids photos, and what they are exactly doing. They are playing, they are doing something, the activity, funds. Okay, so many things, chocolates, maybe ice cream, whatever, right? So what is that thing the client is requesting, but the data what we are searching exactly, but I don't want all the information. I want to search uh, certain age, like 5-year kids. What is the diet, or we can't say it as a diet. What is the healthy food for the particular kid? The age is from 5 to 6. Okay, so if that is the thing, we are going to exactly retrieve what we are actually searching for. The remaining data we will omit. Okay, so this is what usually happening. So I am the client, I am searching for a request kids information. The server is providing and giving to me. Okay, so I got it from the first page. I need only kids healthy food. Okay, so I should search it in such a way that kids healthy food. Some of us may be searching for exactly to obtain the exact content. Some of them are giving generally. Some of them may be used different types of languages. So that is one of the major things what is related with the NLP in Google. They are facing some issues. Some is good, some is wrong also sometimes. Okay, so something is there. So kids healthy food is my requirement. I should search it in such a way. Okay, so what is the function of a server there? It could retrieve everything and it will prepare and send it to me. If I'm searching again kids healthy food, it will retrieve some other thing. So exactly we could find after we have to satisfy with what we are retrieving. Until that the process will continues. Okay, so this is what happening in request response model. The next is publish subscribe communication. Publish subscribe communication. So what is publisher? It sends messages to the topic. It sends message to the topic, and the message published to topic 1, topic 2. Okay, so what is publish subscribe? I'll tell you first, then we can go for diagram. Publish subscribe is a communication model that involves 3 people. One is publisher, another one is broker, another one is consumer. Okay, so publishers are the source of data. They can send the data to the topic which are managed by the broker. And one more thing, the publishers are not aware of the consumers also. So the broker acts as an intermediate to accept from the publisher. They should reach the consumer with the help of publisher. Okay, so the consumer subscribe to the topics which are managed by the broker. So the topic may be available in any category. Okay, and when the broker receives data for a topic from the publisher, it sends the data to all subscribed consumers. So what you are doing with the YouTubes and all subscription, you know what is that, right? So based on that, that particular consumer can consume it. Okay, so this is the thing behind publish subscribe communication. Okay, so publish subscribe is a communication model which involves 3 people: publishers, brokers, and consumers. Publishers are the source of data, that is what we need, sends message to the particular topic, and it can be available in any one of the category of the broker, and the consumers may also be involved in any of the topic, and the consumers subscribe to the topics which are managed by the broker. Okay, so these are the functionalities what is happening. For that I draw a small diagram and it was given to you. Okay, go through it. YouTube is a thing example, or if you want to deliver give your publish your content wherever, so this is one of the model. We can't do that thing as directly. Okay, we can't reach the consumer directly. So we need a broker. That is the concept here. Okay, ma'am? Fine. The next is push-pull communication model. Push-pull communication model. So there we have publisher and consumer alone. Publisher and consumer. There is no involvement of broker here. So push-pull is a communication model in which the data producers push the data to the queues and consumers pull the data from the queues. Okay, so imagine your queue, how you are standing in a queue. So what is the concept of queue? Anybody can tell me? Queue, normal queue. You are standing in a queue. What's the concept?
First in, first out.
Yeah, good, very good. First in, first out. So those who are entering first should have to come out from the queue first. For example, if you are buying tickets in movie or anywhere, right? You are going in a line and moving one by one and to obtain the tickets. Okay, so that is one example. And push-pull is a communication model in which the data producers push the data to a queue and consumers pull the data. They can utilize it. Okay, and the producers do not need to be aware of the consumers also here. Here also the producer, there is no need for the producer to be aware of the consumers. And the next thing is the queues help in decoupling the messaging between producers and messengers. Okay, so it could be capable of providing connection in both the ways. Okay, that is what given. And the queues also act as a buffer in the sense storage, temporary storage, which helps in the situation when there is a mismatch between the rate at which the producers push the data and the rate at which the consumers pull the data. Okay, if it is not coinciding, okay, so on such case the queue will act as a buffer. Okay, it will keep the data for some time. Okay, ma, fine. So for push-pull, I don't have any example. If you people know, we will discuss once the first unit is over. I'll try to search. I haven't searched. Fine. And the next is exclusive pair communication model. Or you can take any FIFO system or first in first out system or any algorithm what you can apply it in to perform the task of operating system, something like that we'll think of. Okay, we'll think of. Okay, fine. The next thing is exclusive pair communication model. So exclusive pair, this is a very efficient and very good model compared with all. Client and server is there. It is a bi-directional one. First thing is it's a bi-directional. And second thing, it's a fully duplex communication model that uses a persistent connection between client and server. Okay. So we are calling like a handshake mechanism. This is like a handshake mechanism. Handshake mechanism in the sense TCP. You could remember immediately that transmission control protocol. What we are doing with our internet. Okay. So we are sharing a common server, but even though it is that, we are receiving response, right? So that is the handshake mechanism. Whenever I am sending the data, immediately it should be acknowledged whether what is the status, what is happening in the server. Okay, so that is to be TCP. We will discuss in detail in one of the module. I don't know, that is the third module, I think. Okay, we'll have a more description about TCP there. So exclusive pair is a bidirectional, fully duplex communication model that uses a persistent connection between client and server. So once the connection is set up, it remains open until the client sends a request to close the connection. Okay, and the client and server can send messages to each other after connection setup. Okay, so request to set up the connection, it responds accepting the request, message from client to server, message from server to client, connection closed request, connection closed response. So everything will be immediately indicate or informed to the client. So that's why we are calling this as an efficient model. Okay, fine. So what we are searching in our Google or net, we are using our net, we are providing enough flexibility to access our net. So that is a very good example for exclusive pair communication model. Finally comes IoT communication APIs. This is the last topic of logical description. Okay, I think you could remember, don't confess. I have given, see, if you are taking logical design, there we have three components: functional block, communication models, communication API. In functional block, what is logical design I have given. Next, what is functional block? What are the components involved? For that I have given you a description. The next is communication model, second category. There we have A, B, C, D. Okay, the subdivisions are there. what are all those things. Okay, the description is enough, description is available. Third is IoT communication API. So there we have two terms. One is REST based communication API, second one is web socket based communication API. Okay, so don't confuse anything, don't put something in something. Okay, so that is also not right. Fine. What is REST based communication API? Okay, REST based, rest in the sense representational state transfer. Representational state transfer. It is a set of architectural principles by which you can design web services and web APIs that focus on system resources and how resource states are addressed and transferred. Okay, so we are calling it as a diagram which consists of HTTP clients, HTTP packets, HTTP server and few resources. Okay, and what is that representational state transfer? It is an architectural principle by which you can design web services and web APIs which focus on system resources and how the resource states are addressed and transferred. Okay, you can make use of REST based communication APIs for your project implementation also. And the REST based APIs follow the request response communication model, what we discussed the first. Okay, the first architectural model. And the REST architectural constraints apply to the components, connectors, data elements within a distributed hypermedia system. So wherever it is necessary, it could be capable of applying. So I brought few things here. For HTTP client, REST HTTP client is there where we are providing the request. And HTTP packets get, put, post, delete, you know, what are the HTTP commands. And XML can be used, okay, for a payload I have given here. And server authorization or full web services, we could be capable of retrieving from few resources. Okay, ma'am. The next comes a web socket based communication API. So this is a bidirectional and full duplex communication between clients and server. And it follows exclusive pair communication model, what we discussed as last. Okay, the last model, it is a very good model. So that can be used for this WebSocket based. So I have given a small layout, a request to set up WebSocket connection. The server will respond accepting the request and we are sending the data frames, whether the data frames are okay, how much data frames we are sending. And there is a bidirectional communication, so we don't have any issue. And finally, connection closed request from the client and connection closed response from the server. Okay, ma'am. So this is with this your logical design is over. And the last topic of first unit is security. Yeah, I'll drink some water. So what is security? What for we need security? So in that previous slides, I have given few things about security then and there. So IoT security is the technology area concerned with safeguarding connected devices and networks in the Internet of Things. So how many components you have used, what are the things you have used, everything should be safeguarded. Okay, so that is the main purpose of secure IoT system. And second thing is, the IoT involves adding internet connectivity to the system of interrelated computing devices, mechanical, digital machines, objects, animal, people. Okay, we are going to link everybody here. So each thing is provided a unique identifier and the ability to automatically transfer data over a network. Everybody is having a unique identification. So they could be capable of communicating with all. That is the meaning for the second statement. Finally, it allows the devices to connect to the internet, opens them up to a number of serious vulnerabilities if they are not properly protected. Okay, so where it should be open source or where it should be a closed terminal. Okay, so that should be known and the user should have to make use of in such a way. Okay, all of our data and programs should not be shared. Okay, so that is the one more secure mechanism we need for IoT devices. And these are the characteristics. So implement microservices, physical security, firmware updates, strengthen authentication process, isolating the devices, limit access, device monitoring, end-to-end encryption, and IoT security breach plan. So these are the characteristics involved in IoT secured mechanism and how the things are happening. Each and what is that microservices means? Each and every device may have some like a small chip, and we could be capable of providing those connection. So it is possible, but it should be safe. Okay. And physical in the sense, what are the structural components? What we discussed in physical layer, everything should be secured. Okay. So we have certain updates for everything that should be compatible to the that should be compatible to all the IoT devices. The authentication process may be strengthened. For example, you people are working with a banking system, right? Initially, we have a uh, OTP, and yeah, we also have now also. But in State Bank, yeah, of India, we have now immediately we are having uh, OTP, right? Immediately it would be asked us. I am talking about a net banking system. Okay, so something should be enhanced then and there. So whatever may be the enhancement or scalability, the thing should be adapt with everything. Okay, so strengthen that authentication process. And the IoT devices can be isolated also wherever necessary. Okay, so for few functions it may be added, and for few things it is not necessary to keep the architecture as such for everything. Okay, so it can be the access may be limit based on some capability as well as ranges. Okay, so if you are using Wi-Fi devices, right, which each and every devices, your Bluetooth is capable of having frequency range from this to 20 to 200 megahertz, something like that. And if you are using other Wi-Fi devices, how much the data can be transferred, how long it would be capable of transferring, everything is there. And all the devices should be monitored. By that way we can achieve secure. And end-to-end encryption. Okay, so you know about what is I think encryption mechanism. The data should be hidden, and right, cryptography, it is a technique what we use for secure mechanism. If you want, you can implement that also. And breach plan, 1 minute, I it is one more task we have in IoT. Breach. So what are the like responsibility? Okay, so an incident response plan should be set up to address a suspected data breach in a series of phases. Okay, if this type of things are happening, how it would be identified? Okay, so that is said to be breach response plan. Okay, security breach response plan. So that also should be aware of if you are making use of that IoT devices. Okay, ma'am. So with this, your first unit is over. I have prepared 50 slides. Yeah, yesterday I have not uploaded your textbook. I'll make it now today evening. I have one more class at around 5. So after that I'll make it. Okay. So yeah, any doubt in today's class? We finished first module.